Hi, I'm here with Chris Reynolds from AVX. And in the power area, a lot of the attention gets put on magnetics, but in actuality, there's a lot going on in power capacitors as well. Chris, tell us a little bit about some of the developments there. I see we have a film capacitor that's kind of beefy here. Why don't we start with that one?
Okay, these are the FHC1 and FHC2. Now, for film capacitors, one of the big driving applications now is DC link in HEV. So the factory has been making DC link for years. It's their specialty for trains and heavy industrial applications. And if you go on the SNCF and the high-speed trains in Europe, all the DC links and the catenaries are usually powered with these huge, refrigerator-sized caps. Now, you have exactly the same application in a vehicle, but you don't want that size of cap in it. So the research over the years has been to be able to make thinner and thinner films that will take a very high voltage, and the thinner they are, the more windings you can get into a small volume. So these are built up with individual bobbins, all in parallel in a three-phase system. We make them in different configurations of terminal to match directly to the IGBT that they're linked with smoothing. And these two are coming out now for the higher CV per volume and per weight for the new generation of EVs. And some of them we do as well with an extra two terminals, so you can have access to snubber control as well. Many of them are custom built, for the vehicle compartment that it's going into. But we have a lot of these off-the-shelf types for people to just use and make sure they've got the right requirements. Because with the DC links and the film, you have to work with the mission profile of the vehicle. Because these use controlled self-healing in them, so they will never fail. But there will be a degradation in capacitance if they're run hard. So we make sure there's enough margin in the design that after 5 or 10 or 15 years, they're still within 10% of the initial cap value.
A cap in that package size, what's the capacity of something like that?
They go between 600 and 900 volts, and we'll do 500 microfarads, but they have to be able to take surges quite a lot higher than that, obviously, and that's another part of the design.
They have some other examples here. Why don't we talk about those?
Yeah, just while we're on the same film design, these are just single bobbins, but very large, and they're just for bolting. So rather than using a single device, if you've got an industrial design, you can just bolt these directly to the bus bar and achieve the same DC link characteristics that way and build this up with discretes rather than doing it with a module. The other thing that we've got going on is the new super-capacitor. We started off 20 years ago with a special type of super-capacitor based on a proton polymer film. As you can see, for a super-capacitor, it's quite small, very low profile, and these started off by having a proton polymer membrane to do the charge separation for the high cap. These are ideal for put into very small applications, SMD, or for just matching up to a lithium-ion battery. The characteristics of these are they can go to very high voltages. But we've actually diverged from those types, and we've introduced more traditional type of supercap based on lower voltage cells, which we can also serialize internally. And this series is the SEM series. So these now are in the 5 to 10 farad range. Some low voltage applications. Going up into the other release that we have is very high energy density pulse power handling. These go up into the tens to hundreds of farads. And also we'll do these at higher voltages as well.
Can you give our viewers an idea what some of the applications might be for this?
Yeah, well, any pulse application, if you think of the earlier type of supercap, when you have something like a laptop and you want to do an internet connection and you want to do an upload, so you have to have enough instantaneous current on GPRS that is too high for the internal battery to supply because of the resistance. So these things give you that burst of energy on demand, and at this level they will do the job of a bank of 20 tantalums, deliver that energy on demand. This is industrial scale pulse. So this is like industrial switching equipment, also in automotive. If you want to deliver an acceleration of an electric motor just for short periods to get it going and then have it running flat for a while, these are the type of technology that will give you that build-up. Cool. So the very wide range of industrial pulse power switch-on applications. The next type that we've got is coming down to the smaller devices in our tantalum family. So these are the traditional SMD tantalum caps. The black ones in here are part of our F9 series. We have a standard series of caps that we do for manganese and for polymer. And then we do AEC Q200 versions for automotive. Now, again, in line with what's happening in the world of EV, we're going to wider bandgap silicon that we have to support that tends to run hotter. So the core temperatures in a lot of these applications are going to exceed the standard 125 degrees. We made quite a while ago the high temperature tantalum, the first to 150, our THJ series, which went to 175. We now have the smaller version in our F series that goes up to 150 centigrade. But the advantage of it is it gets to higher cap for the same voltage as the earlier series. So we've now got in a 1206 equivalent size for the J-lead tantalum, 10 microfarads at 16 volts, which exceeds any ceramic AEC Q200 qualified cap. So now you're getting into a lot of these applications for decoupling and bypass, which are close to the high temperature core that will actually, you can use miniature components for 150. The other thing is all our professional caps, whether they're automotive or industrial grade, a lot of them come out with an enhanced reliability from a more conservative design. The standard 1% per 1,000 hours, 85 degrees is the benchmark. A lot of these 0.05% per 1,000 hours, so 50% better reliability. This particular one, especially at the 1206 size, it's 0.05% at 105 degrees rather than 85 degrees standard. So it's like a double reliability factor compared to the others. These are starting to have a lot of success in the MEMS applications and even hybrid applications that are still used under the hood.
That's hot stuff, isn't it? You've got a big capacitor over here that you wanted to show us. Can we talk about that a bit?
Yeah, and that, again, as I say, is an extension of the pulse power applications, but where we have some very large cells in series for very high automotive voltages, 48 volts and up, that deliver a huge amount of, not quite kilofarad range. But the idea of those is for fleets, for buses and things like that. The buses can be all electric or they can be hybrid. The whole point of the hybrid ones is that they use most of the diesel when they're accelerating. What these do is they will actually supply the energy to do the acceleration, so the diesel is just used for the constant running. And it reduces the diesel consumption by up to 60 or 70%. Plus, the braking system can recharge the supercap, so you don't get that wasted energy from braking.
Yes.
Now, in EVs as well, these will actually do the startup for an EV, in addition to the DC link that does the power filtering. These are quite big units. They have to operate over a wide temperature range as well, just going through normal northern to southern cities, for example.
That sounds like a very useful thing to have if you have to do regen.
Oh yes.
Where would people go to get more information about some of the applications you've been telling us about?
Everything is available on our website. For all of the new products that we have as well, we make sure that there's products available on the shelf for all our supporting authorized distributors as well. So either through the AVX direct website, or if you're looking for parts, you come through the major distributors and you'll find the product there.
Well, Chris, thank you for that. It becomes obvious why capacitor technology is so important for some of these high technology power supplies and power applications. So thank you.
Okay, you're welcome, thanks.